Thanks, Steve, for taking the time to join today with us and as part of educating and giving the frontline vision of what you're practicing with data science and machine learning at Discover. Steve, explainability is all the rage today. Why is your team and why is your practice focusing so much on machine learning, interpretability, explainability, and bringing more transparency to our decisions in using machine learning?
No, that's a great question, Sri, and again, thank you for having me today. And I'll put a plug in. We have a paper out there that Sri was certainly supportive of, called Considerations, and it kind of goes through all of this. So we'll try to provide that link in the chat as we go forward. But for us, really, explainability is a necessity in consumer financial services. The requirements of the regulations are that we were able to tell people why we're turning them down for personal loans, credit cards, any type of loan, and that kind of necessitates explainability. So for us, the journey really started 3.5 years ago, because if you wanted to use machine learning to do underwriting, again, in this niche, then you had to be able to explain why you were declining people, right? And that really was the beginning of our journey. But it's really the kind of the domain of our business activities really kind of forced us down explainability. I mean, in short, Sri, it's we had to, right? We couldn't use machine learning unless we could figure out how to explain it.
I mean, in the beginning, we started with using very simple algorithms, right? So they were much more easy to understand. Is the nature of more sophisticated, as you started using more sophisticated machine learning algorithms, what were some of the challenges you faced, and how did you, what methods / what techniques you ended up resolving?
Again, there's really kind of two pieces that, two reasons why the decisions are harder to explain than in the old world where it was logistic. One is simply just the number of variables that or attributes you're allowed to, that the methodology allows you to use to solve the problem. With Logit, you quickly get multicollinearity. So you're really kind of forced to a pretty small, finite number of attributes. So it's pretty easy to explain the interaction of those attributes and come up with your adverse action reasons. When running, in running machine learning, the sky's the limit. That's a different fireside chat about how many variables you actually need, but you can put as many as you want into the system and get an answer. Maybe not the best answer, but you can get an answer. The second piece is really just the algorithms. The algorithms themselves don't lead themselves very well to being explained. And that's kind of the commentary around black boxes.
So you're saying we don't need just 20 variables like back in 80s and 90s?
Well, I joke with my data scientists about this. The consumer retail lending, unsecured business is over $1 trillion in the US. So Logit was pretty successful, I would say, in generating receivables and generating profits for a financial services company, and also allowing people access to credit. So, we went a long way with 20 variables. And the joke, of course, is that if, when we have another $1 trillion of machine, generated with machine learning, then you can start saying bad things about our ancestors.
Now, at some point, you mentioned black boxes. That's a great segue. There are two different places where typically opaqueness creeps in. Like one is, of course, people and processes, and then, of course, and machine learning methods and data. what are some of the measures that you've kind of proposed, or measures that you're using even internally to kind of, so a logit is obviously the most transparent exposition of using math, but of course it's not as powerful as you go towards some more non-linear domains. But then, so do you have a hierarchy of algorithms that are more explainable, and the ones that you're using, and different kind of data sets that are much more safer, if you will, in terms of using in credit?
Yeah, I'll take the data question kind of first. Again, it goes back to the domain of the problem set, and with consumer lending, again, it goes back to the adverse actions, or the need to be able to express to the consumer why a credit decision was made, which means that we have to use FCRA compliant data to make those decisions, right? So, for regulated banks, the data is relatively narrow that we're allowed to use. And kind of the language is around the nexus of credit, right? There has to be some linkage, logical linkage between the variable that you're using and why it would be important to the prediction of default, for instance, right? So, what you'll see is primarily credit bureau data, time series on the credit bureau data, and then credit bureau adjacent data, which would be the telecom data, utility data, rental data, that kind of thing. There is a big push right now to go into cash flow data derived from the DDA accounts, but that's relatively new. And then, of course, if you go down one of those services as a consumer, you would have to opt in to provide that data.
What are your, someone's getting started with going from data science to kind of say deep learning or machine learning methods. What are certain things, guideposts, guidelines you would give them in terms of being safe, guardrails, as they start deploying machine learning?
Well, I think the advice I guess it's not quite directly answering your question, but I think the advice to the data scientist is really kind of step back and think about the domain, right? So if you think about data science is kind of inward looking. It's about the data and the algorithm, right? But to drive value in business, you need to kind of step back and think about the domain. And a simple way to think about the domain is really the product, the process, the data, and whatever's really important to that industry. For us, it's really regulation, right? But the fourth one could very much be competition. We were joking it would could be the size of the cricket pitch, right? The makeup of the grass, because all of those things influence the problem that you have to solve, and what are the constraints to solve that, right? So it's really to kind of step outside of the kind of internal focus of the data science and step into the domain and outward looking to understand the upstream systems, the downstream. We can provide an example, but so you come up with a great prediction of somebody that's going to charge off next year, right? Defaulting on their loan next year. What do you do with that, right? I mean, there's regulatory issues about how do you explain whatever you're going to do, but what do you do with that, right? I mean, what levers can you pull? What value streams do you have? What processes are in place to actually take that insight, that individual level insight, and try to make value for company with it.
You have an incredible team, Steve, and building and retaining data science and domain expertise in credit lending. It's a very small world. Almost every one of our customers is interconnected as well. So how have How have you coped with obviously the last year of building team, maintaining them, keeping them focused during the COVID, and now as it reopens, how are your strategies changing in trying to build world-class domain and data science expertise at Discover?
First I have to say that I'm lucky, right? I mean, I was able to, at some point we were able to attract some really world-class data scientists, and I use the term data scientist pretty loosely because we have a pretty mixed team of mathematicians, computer scientists, econometricians. We have, I'll get some smiles out there. We have both agricultural economists and economists, but it's really about putting together a diverse team in the sense of in kind of the academic sense, and then, providing some really interesting questions and problems for them to solve, and, kind of taking a step back and just letting them get it done. We've been, I think, fabulously successful with that approach. Coming out of COVID and expanding in our scale, it's kind of an open question because we do have a really, at some point we've developed a very good culture, and as you start to scale it, one of the questions is always how do you maintain that culture, right? How do you bring people in that will support that culture and support really our vision that we're wanting to move forward on.
That's great. And I think as you, I mean, domain knowledge is crucial in trying to make sure the right questions are asked, right? So in terms of detecting bias, what kind of methods / techniques and audit do you apply internally, whether the bias is coming from the models or from historical data? What occupies your mind and tools, tool chains you have there?
I mean, I think the bias is really going to come from the data, right? That it is possible, and we're very early into these days. I mean, outside of the kind of the traditional processes that we use for bias, that an algorithm in my mind could certainly exacerbate the bias that's in the data or mitigate the bias in the data. And I think the issue here, or the opportunity, I think it's much more of an opportunity, is that with all of the power that we have now on the CPU side and the IO and the data side, we really should be able to put those tools to focus on mitigating the bias that we see in the data through the algorithm, right? So, at a very high level, I think that's what we're trying to do. And it's all, it's all very new and very cutting edge right now, is to really look at, instead of in the past, you would do the bias mitigation post hoc. So you build the model, you send it to the compliance team would run some tests. If there's issues, kind of a back and forth until everybody feels comfortable with the model and you move forward. What we're trying to do is push the bias decisioning as part of the optimization of the actual model. As we're looking for the right level of performance in the model, we're managing the amount of bias, during that process.
You talked about the paper briefly, considerations in machine learning. I'm going to just flash it on the screen here briefly. I mean, you do talk about kind of the measures and definitions of the space, right? I mean, do you want to touch brief on how some of that, especially around kind of discrimination and disparate treatment and impact. Be a good one to bring the audience up to speed on.
Yeah, so I mean, that's, you know, we certainly can talk about it. At some point, the reason we wrote the paper, I'll kind of go back to that, is that there's a lot of different uses in the language that people use. And we would go to, this was all before COVID, or it started before COVID, go to conference and, people are using bias in 20 different ways. And so we were really trying to kind of write down how we were using the language and hopefully it, being a pattern for other people that were participating in that language. Because I don't want to be the old guy, but kind of the whole YouTube, right? You're not going to understand, from a 2-minute clip from YouTube about disparity and impact and disparate treatment. At some point it's written, the written word is much better at kind of expressing, detail and difficult or nuanced thoughts, right? But, again, at a high level, essentially, disparate treatment is treating a protected class differently than other classes, right? And so that's basically a per se violation. Disparate impact is a little more of a nuanced thing, is that, and this comes back to the biases in the data and the black box, is that, if at the end of the day you ended up treating unknowingly, but treating a protected class differently, then you would actually be a violation of disparate impact. So they're pretty high bars when it comes to, bias, and then of course you can't get to bias without explainability.
Training our guns and thinking a little more onto the post hoc explainability. There's a bit of two camps in there. Some folks who believe that post hoc explainability is actually not real, or it's just a window dressing of a preconceived hypothesis. And some others who say that explainability has just been the end-to-end life cycle, starting with the data selection itself, not just waiting for model selection. Where do you or your practice fall in that?
Again, I go back to you got to understand the domain that you're in, right? And even within, the domain, the domain that we're in, right? The consumer financial services, right? There's a continuum of transparency that you need, right? If you're doing, if you're building models that are, bidding for, website messaging, I'm not sure how much explainability you need. There is some UDAP issues, and there's some, fair lending. There's always issues on the regulatory side in our business, but that's very different than making an approved decline decision, right? So you really have to kind of step back, understand the regulation, understand what's appropriate, for whatever decision that you're trying to do, and then map towards that, right? I find I think it's very important to have very detailed discussions about explainability and post hoc and interpretability as opposed to explainability. But at some point, those things are, I think they're a bit distracting of the whole, right? Because what we have to do for underwriting decisions is different than what we have to do with other decisions, anti-money laundering or fraud, or there's different pieces here that are under different types of regulation. But I think it also, I guess my point is, we should have those conversations in respect to the problem that they're important for, right? and step back a little bit and talk about, how much transparency do you want on a self-driving car, right? Or if you're trying to do something like diagnose illness, in a place that has, perhaps less developed medical than we have here in the U.S. How much transparency do you actually need, right? And I think that conversation about transparency, which really is kind of leads to a loss or a mitigation of risk kind of conversation, I think is really kind of the important one to have kind of across the board. I think we get, again, I think it's kind of that inward looking data scientist, right? It's just like, we are going to talk about the best explainability methods until we retire, right? And at some point I'm saying, okay, that's important for certain questions, but we really need to kind of pull ourselves up and kind of, decide whether we really need that across the board, and how we can use the power that we have now to do more, social good in the world.
Thanks for that. Not lose the forest for the trees, right? Sort of. So, no pun intended about the techniques we end up using. If you zoom out to kind of, essentially your comment is for fraud prevention, you're going to use different level of, there's a different level of need and demands for explainability or transparency, and while trying to give lending or give loans, you probably want to be completely clean and come up with as much due consideration as possible to be fair. So, what kind of themes occupy your mind when you're trying to kind of take these models through a full-fledged review, either with one of the regulators or even within Discover? What are the considerations in your mind when you're challenging your own models and validating them?
Yeah, again, I think it's I'm going to open every response with domain. It's going to be, we'll get some t-shirts made. Again, when we set out, whatever, a little more than 3 years ago to do this, it's just, we knew the domain well, right? So, I 2 decades ago, I built underwriting models for one of our competitors. That was my first job in the industry. So we well understand the domain, right? So we know if we want to get if we want to do machine learning, there are certain things that we're going to have to do. So kind of the answer is we didn't at the end, we didn't say, okay, what do we need to do to make sure that we could actually use these things? And, how do we get them through our validation with our model risk management, and how do we prepare for an exam, right? We started day one saying, hey, we need methodology, right? And we need a process to make sure that when we are done, we feel comfortable for whatever exam is going to come, right? So, we approach things in a very rigorous way. We write things down. We work with our legal and compliance partners, from day one. We've been very open with the rest of our organization about what we're trying to do and where the risks are, and hand in hand with our model risk management team. So when we're there, which, at this point, we're comfortable that, when, it's not really if in our line of business, when the regulators come to do an examination of us, that we're ready, that we have the answers. And part of that is the paper that is now, the link is posted out there on the chat. But we've also have a couple of scholarly articles that are in archive that really kind of support our process.
There's an interesting question that popped into the Q&A, which is, how do you teach domain knowledge to a data scientist team? And usually it's a good loaded question, right? Do you start with a banking expert and teach him data science, or do you start with a data scientist and get him in front of customers and get him to learn more of the processes and operations. And I've seen exponents of both these start journeys, but what would you recommend?
I don't know if there's one path. I mean, it is an open question, right? I mean, it's as we, you think about scale. I think we lost Sri. But if you think about scale, part of it is how do you build your models more efficiently? How do you run them more efficiently? But also, how do you generate the resources or the human capital to do that, right? And to put it in kind of a sense, though, right now, credit card company will run on 100 models or, somewhere around there, all in. But with where we want to go, with digital interaction, journeys, all of the data that we have, we're talking about moving from 100 models to 1,000 models, right? So we're not going to hire 10 times 10x data scientists, but we do need to hire, we do need more data scientists, and training them is the question. 20 years ago, you solved it by hiring ag economists and economists primarily, and some statisticians, and then you put them in a modeling group and they would learn the business that way. Now the data sciences seems to be coming more out of the technology groups, out of the IT firms, which are kind of distinct from the business groups. So it is a open question, but hopefully with the kind of the agile approach where we're working with cross-functional teams, that we can train them on the domain in those agile teams, supplemented with in-person and web training around the business. But it's really important, again, the career path for, I think, most people is going to be into more of the domain. The Kaggle masters are the ones that are going to continue on their path, which is on the algorithms, but the rest of us, maybe not as smart, at some point have to go to the business side, learn the domain to drive value.
I saw an audience answer to that. Urmanpreet Singh says that he started with an MBA and then learned data science and is now able to do digital lending solutions just as well. So I'm pretty sure that the journey is both bidirectional. One of the things we are actually seeing is a different trend where data scientists are being asked out of their incredible multidimensional nature. They're being asked to produce software, right? Sort of almost on a daily basis, deploy code, deploy models, not just notebooks, right? Beyond from notebooks to actual software. Obviously, H2O has some software stacks that allow them to do that. But in general, how are you coping with model lifecycle, just like software lifecycle?
Again, highly regulated environment. So we, track performance as mandated by our model risk management group as a function of the overall regulatory regime that manages the large banks. But it really is about, why would you need to change the model, right? So, either the data has changed that is feeding the model, the framework of the structural relationships within the data has changed, right? Or your population that's coming, through the model is changing as well, and your model wasn't generalizable enough to begin with. So, those, I think we have to be careful about pushing, new models quickly into production for various reasons. But I think you take on a lot of risk. And I guess another piece, I'm kind of all over the place on this answer, but it's really what the performance window is, right? So, you know, a credit card default model is going to be, you know, you'll have them on the short side, the 6-month models, and then you'll have them on the long side, the 18th month models. I've seen them out as long as the 24 months, right? So these are really long-term predictions, right? So there's not a need to, like, you know, recalibrate or rebuild, you know, rapidly. And the large structural changes in the data really are really very infrequent. You know, we've seen them in my career. We've seen mortgage used to be, if you had a mortgage, you were good forever. That changed in 2008. Suddenly, if you had a mortgage, you were bad in the data. You know, then, so that's one example. Another example is that the industry grew and specifically, or changed. Specifically, personal loans were a very small part of lending prior to like 2012, 2014. So you see the predominance of those things growing, right, affecting the underlying structure of the credit data. And recently we were looking at some mortgage data. So mortgage is back. You know, mortgages, you know, is a good indicator now. You know, so, but those are large structural changes in the interaction of the independent variables that you kind of have to manage. That said, I did, you know, there are times, you know, when I go back to like the bidding models, that you'd want something much quicker, because those are the framework of the data is really determined by your competitors, right? So if the competitor's in and out, or, you know, one of the large competitors decides to drop a whole bunch of money on a certain channel, right, you may want to recalibrate your model or rebuild your model at a much rapider pace. But it really, again, it goes back to, I'll end the question this time with domain.
Someone has a much deeper double-click question. Mike Easterly says, okay, let's go one step into the domain knowledge versus inward-looking data science debate, right? And can we give any specific example where a different model like random forest or a neural network is used, or a different technique? And we couldn't have had a conversation without bringing up Shapley, right? Sort of different technique is used upon based on the domain. Are you finding the usage of, say, a one drop one or input median, impute median, or Shapley methods? Are you finding certain techniques more conducive to certain domains, and vice versa, certain algorithms more conducive to certain domains? And I can answer the first version of it. We're seeing, for example, random forest is the king of the jungle in fraud prevention, right? And it adapts. It's really very robust. We're not seeing a lot of Shapley in fraud prevention, right? Sort of the extreme example is kind of, we're seeing a lot more of kind of much more quick scoring and retraining and reinforcement learning, even to some degree, deep learning. We see a lot of deep learning as well, but GBMs do the trick for the most part on transactional and time series data. But it'd be interesting to see what your experience is, Steve.
Again, I think I mean, we're just talking all this, the domain talk. It really depends on what you're trying to do. So you know, when again, going back and saying, hey, we want to use machine learning in underwriting, right? Explainability becomes the number one, right? So you know, you start thinking about how explainable certain algorithms are, right? And which methodologies of explainability that you can bring to those, right? So, and then it's also dependent on the infrastructure that you have to put these things in, you know, into production, right? You know, and you know, kind of that, and I can give it an old school example of that, but it really is I mean, everybody's very new to this, right? So we've kind of settled on certain things that we like, But I really think that in the next 18 months, 24 months, that we'll see a large push for adversarial models. And I think without those adversarial models, it's kind of hard to say that this algorithm is better than this algorithm for this space, right? Because, you know, at this point, you know, beating logit is really the exercise, and that's pretty easy to do, right? You know, now we need to kind of like, okay, you know, do we leave something behind, or did we create other problems, or what were we blind to when we made that change, right? And that's really kind of the adversarial model. So I think the true answer to your question is really, you know, to be determined with some more work.
I think adversarial data testing, modeling, that's a great answer and a great segue. That's a phenomenal technique at the hands of, we've built some applications in our app store. We have an adversarial model tester that essentially creates data that tries to stump the model. And it's using essentially some form of our automatic machine learning to throw data at the model to see what it's to uncover its blind spots. Right? So, how have you dealt or coped with, and that's where the neural network regime comes in, is with NLP?
We're at the very early part of natural language processing. You know, when you think about our journey, and you know, and kind of how people should think about, maybe offer a framework for thinking about other people's journey, is that, you know, to do something, right, to drive value with machine learning or AI, however you want to phrase it, you have to have processes in place, right? You have to have the data in place, and you have to kind of respect either your regulatory regime or the competition or whatever it is. And when we talk about process, it really is the, you know, if you're going to send a text, right, is there a process in place to send a text, right? Do you have the creative to send, right? Do you have the, you know, you have the journey defined and things like that? So really kind of the first kind of approach, or the first kind of stage is, hey, look where you have logistic models, and figure out how to, you know, upgrade to some, you know, whatever machine learning model that you want, because you're going to get some pretty significant lift. There's a lot of, you know, there's a lot of hurdles, at least in our business, that you have to overcome, but you'll learn a lot through that. You know, and then the second kind of stage is, let's start looking at problems that we've not necessarily been able to solve before, right? Because the false positive rate's too high, right? Attrition is always the one, you know, people are going to attrite, right? And, you know, the false positive rate determines how much you can spend to keep them from attriting, right? And we've never really been able to get the false positive rates low enough for that, to really do that. But, you know, so there's both a analytic issue there and a problem solving issue there, but also, because we've never solved that, there's no processes in place, right? There's no, you know, we don't, you know, we have to either, you know, bootstrap into some other thing that exists, like providing additional rewards, or, you know, giving them, you know, sending them a gift card, right? Those processes don't exist. So it becomes more difficult to go into stage 2, right? And then stage 3 really is, you know, using the technology and kind of rethinking your product, or rethinking about how you approach things in a completely new way, right? And the NLP is kind of in between 2 and 3, with some exceptions around compliance monitoring, you know, and providing advice to the people that are on the phones.
Well, I mean, challenge with NLP, of course, is they're quintessential black box models, right?
Yeah.
So, but I think some of the work we've seen recently, right, like the checklist from Samir Singh is one of my favorites, is basically, how do you determine monotonicity in sentiment, right? So if someone's saying something and someone's saying that more, is it getting more negative, more positive, or suddenly you change a keyword in that same sentence and suddenly monotonicity goes through the window? So we're beginning to kind of build some tool chain on this and start kind of carving this main problem out as almost like a series of micro apps, right? So this is our app store. You can see, you've heard of that before, but explainability is becoming more and more. It's not just Shapley, it's not just MLI. There's a lot of little things that people do to kind of codify, and I'll pull up adversarial tests that you kind of brought up briefly. How do you codify kind of a series of methods and methodologies you can bring to bear? Here we're doing some adversarial testing against a model, so we can break it down and start looking at what features are more prone to attack, right? Sort of, and what features are less robust, and how do you kind of perturb the data to create maximum error in the models. Things like these are becoming more and more common. And as NLP progresses, we begin to see how do you convert a black box model to more understandable, piecewise understandable model. Back testing, you're seeing a lot of model validation where it's no longer okay to deploy a model without a lot of back testing. So things like that are beginning to emerge more and more as mainstream methodologies, right? As opposed to, obviously you mentioned data drift detection. So you can essentially trigger retrain of the models, but using AutoML as a tool, as opposed to as a tool to invalidate, as a tool to explain, and start using AI to explain AI. So.
No, and it's very it's very exciting to have those tools available. The kind of one comment on that, and then you did touch on something that we could throw out there. But so the question is how you generate value with the tool, right? And that's kind of the whole process, kind of theme or domain theme that I kind of keep coming back to, is that so if we're able to identify something, if we're able to have a better prediction of something, how do you turn that? I mean, at some point you have to affect a customer or an applicant, right? Or a fraudster, right? In order to make money on that, right? And those become barriers pretty quickly the farther you move away from your core processes. And that and I'm not saying we don't want to do that. That's exactly where we want to go, right? But there's some low-hanging fruit first, right? But then so you really then you start kind of driving through the some of these other use cases where we've not traditionally been able to generate value. You did mention on that the stability, right? And that I think that we probably spend more time thinking about stability than anything else. Right, because whatever prediction that you're making, the question is how stable it is, right? On many fronts, right? Because I always kind of go back to local versus global optimization issues back in the day, right? You want to make sure that you don't end up on a local optimization because you move away from that, and your model kind of falls apart. And so I don't know. You have thoughts on that, Sri? I'm going to turn the tables on you.
No, absolutely. I think one of the most profound things that we found out was that locally linear spaces exist. So you can absolutely solve a locally convex problem, right? But and still stitch it together to still fit globally. So that kind of classic concept of fit globally, but solve locally. And I think it's a pretty profound one. We've seen that work at scale. Now, of course, someone asked on the audience a question about neural networks. How do you unwrap black boxes in neural networks? And that brings us to our one of our favorite co-conspirator and customer from Wells Fargo, Gus Gianto, who's kind of talked about his ReLU, right? It's just still a very, I would say, a much more nuanced space where it's still, how do you unwrap black box models? And this technique of using a neural network and getting it in front of a customer in a limited domain, we can absolutely take a linear, a locally linear approach, where this one you're seeing a locally linear model of 23 models matching one neural network, and is able to start presenting a case of what are the features in these local space. You can see the interactions and how those interactions play well together. Now, of course, guaranteed the local versus global performance. How do they match? Those are the interesting next bits of questions. But the interactions show up. People are able to see kind of a completely black box model in some level of linear exposition, and also simply further distillation. And you kind of touch the concept of robustness and stability, but distillation of the model into simple, what are the two big pieces happening in my data? Those kinds of things are just as powerful. But I mean, I think it's obviously we don't have a fairer conversation would be having him on the call, and we attack the LATIA method on how generalizable it really is. Yeah.
Yeah, and I think it's exciting kind of on two fronts, right? It poses the right approach, right? So, for problems that you need high level of transparency and you need a high level of explainability, granted everybody uses those words a little differently. It's an example of where we're not going to take a neural net and push it, in there. What we're going to do is we're going to start from the beginning and say, okay, how do we think about neural nets such that we can solve this problem with explainability, right? And so it's starting with kind of a global view of what you're trying to solve, and then going into very deep and trying to solve that problem, right? So that's kind of exciting. The second one is all the research here is super exciting, and it's kind of it's like an exciting time to be in financial services because of the regulation in financial services. We have to solve these problems, right? So they're not like nice to haves. They're not, we're not deep in a lab trying to do something because we like to say the word explainability. It's that we cannot use these tools in our industry without explainability, right? So, there's direct value being driven by these conversations, and pushing that forward. And that was a long way to kind of get back to all of these methodologies are going to be able to be used across industries, and across social problems that we have, that we can solve with AI.
I think that's a right lens to put on it, right? Are we asking the right question at the highest level? What can we do as practitioners in the space to bring methods to the fore? And this is a very interesting approach. We've tried surrogate models in the past where we can apply locally linear approaches. But I would say NLP is particularly kind of one of the ones that's taken such the BERT models are everywhere. And how do we start checking public models, making sure they're safe, and making sure they're not biased, and making sure they're not bringing in the inherent bias in the last 100 years of decisions in lending and finance. What would you give, and it's a question that popped up in the audience here, what advice would you give in terms of people who are just getting started in the explainability space, right? Sort of what are the big emergent problems in the domain that you would need more attention to, and especially in the R&D side of the world? I know there's a few places where we collaborate with like folks from Stanford or FinReg Law and other places. What are acute problems, and what are problems you see emerging in the next 24 months?
I guess I would start with, helping us, us being a wide range of people, but trying to kind of drive, what do we mean by explainability? And that kind of goes back to my transparency comments, right? It is, and then depending on what industry you're in or what problem you're trying to solve, what is your level of transparency you need, right? And kind of link it back to some, I kind of feel at this point that explainability has become such an esoteric academic exercise right now. It's hard to have that conversation, right? So again, but I think it's stepping back and saying, okay, I got a self-driving car, right? What do I need to know, right? I mean, what is the framework of the knowledge that I want to have coming out of the black box, right? And how do I diagnose that, right? And how do I build tools that are important for that use case? Again, I as we do that, hopefully we can kind of unify a language. Some way I'll get together. We can have the same conversation, but that's a pretty high bar. It is it's a bit of the Tower of Babel at this point. But but the problems range. I mean, it really depended upon the industry, and then they range from, we have very specific problems. We have to tell people why we're turning them down if we turn them down to negative credit action, right? But on the other side, there's a certain level of insights that we'd like to generate, right? To inform our brand, to inform our marketing spend, right? You need explainability there too, but I'm not sure it's the same level of explainability that you need for the credit underwriting.
So that's a great focus, general focus areas, and I think a lot of our customers have a similar thought process. You touched upon AI for social good a couple of times, and wouldn't let you go away without double clicking on that. What role can we play as data scientists to kind of, and at H2O, of course, our Kaggle Grandmasters, our teams are almost leaning forward to bring change wherever we can with our tools, our time, our efforts. We're certainly doing the little we should be doing during the time of need, and it's a privilege to be serving the world on fighting COVID, reopening. And especially during reopening, you'll probably be looking at a lot of businesses applying for loans, and a lot of families trying to extend themselves into the new economy. What general directions would you give to finance professionals and data scientists at this time?
In the beginning, is approach your work with rigor and honesty about about what you're doing, and kind of share some of that kind of across the board. But I think there's a lot more to do. Engaging, participating in the larger discussions around AR for good, I think is a good start. And really being open about, I mean, there's always a, intellectual property discussion here, but being open about, sharing the experiences and approaches to industries that are, or, social issues that are not, that don't have the level of investment and explainability that financial services does, right? I mean, it is, again, kind of go back to where we started. I mean, it is a primary issue for us to solve if we want to use machine learning, but how we can use that same technology, if you will, to do a different social problem. I think that's an important kind of, clearly I don't have super clear answers on how to do that, but being open and try to participate in those conversations, I think is important. And don't be so, and one thing, we're working with a local university to help put together a curriculum, and the it doesn't all have to be machine learning and super technical, right? Workforce management is a data science issue, right? Inventory control is a data science issue. I mean, things can get gnarly and heavy quickly, but there's a kind of underlying theme about using data to make better decisions here, and that can happen at a very local level, and we can help help educate people to to better do those jobs with the technology that's we have in hand, right? So we can kind of create create opportunities for people that you wouldn't necessarily think of as data scientists.
I think data is such a powerful tool. The word data, one of the origin words for data is data, which is from India, which means to give knowledge, to impart momentum and energy. And I think data scientists have a unique role and get that in the fact that they see the 360 degrees or the multidimensionality of a situation, and it bodes as well to, as a community, to lean forward and bring social change with data. And I think this is wonderful to be partners. You, Steve, have been one of the proponents of fairness and bringing a kind of almost a non-aligned view of thinking about fairness and measures in fairness in AI and explainable AI. We've announced that Institute for Fairness in AI with H2O, but H2O is one of the members. We would love to openly welcome more members to that, so we can start defining standards, defining some open source methods there. So super excited with the collaboration ahead, and we'll look forward to thank you for taking the time. And I know you represent an incredible body of folks like Raghu and others on your team who are working relentlessly to make the things that we are working on real. Likewise, on H2O side, a great set of team members working on this to bring some more clarity and transparency to AI, because after all, it's the most powerful innovation of our time, and we want it to be trustable and fair. So thank you for taking the time today for joining us on the Fireside. Thanks, everyone. Thanks, Steve.